Hello everyone, today let's solve the problem number 206, reverse linked list, right? So what the question states here, given the head of singly linked list, we have been given a head of the singly linked list, we have to reverse the list and return the new head. What I said, we have to reverse the list and return the new head, right? So basically we have to reverse the list and reverse the list and return the new head, right? So I can clearly see here we have been given the head of the simply linked list, we have to reverse the list and return the new head. So you can clearly see here 1 2 3 4 5 we have. After reversing the list we have 5 4 3 2 1, right? So that's what we need to return in the form of output, right? So same thing, let's come to the example 2 as well. Here we have been given 1 and 2. Here we have 1 and 2, the output will be 2 comma 1. Quite obviously when we reverse this 1 comma 2, the output has to be 2 comma 1, linked list, right? 2 comma 1 here. This is fine. So same goes with first and second example. Let's come to the third example here. Just give me a second here on this case. So here we have been given an empty list, so we don't have any element, right? So we just return empty itself, empty array itself in that case, right? So that's what they have shown here in the example 3. Easy to understand, right? These are the 3 examples, wonderful examples that they have given. So I hope here all the 3 examples are clear, right? So I hope the question is clear and what we need to do is completely clear as well, right? So let me clean up this one. Yeah, so first what we will do, let's discuss the approach followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially let's discuss the approach first. So first thing we need to note down here is we will be going with iterative pointer reversal. We will be going with the iterative approach, or we will be going with the iterative pointer reversal, right? So I have considered the first example here so that it will be easier to understand. So the first example that they have given in the question, we have already discussed this one, right? So we have the elements 1 2 3 4 5. The linked list consists of here 1 2 3 4 and 5. So when we reverse this one, we need to get 5 4 3 2 1. So the output has to be here in this case 5 4 3 2 1. We have to return the, so this is singly linked list, we have to reverse the list and return the new head. That's what they have given in the question, right? So here the output has to be 5 4 3 2 1. So that's what they have given in the question. So let's discuss this one, or let's understand the step-by-step execution here, right? So the first step is initial state. We are going with the variables previous, current, as well as the next, right? Previous, initially, so here in this case previous we don't have anything, so sorry, not this one, this one 1 2 3 4 5 we are considering here, right? So let me write it here itself, 1 2 3 4 5 we have within the array. So here current we are considering 1, next we are considering 2, previous we don't have anything, so we will consider null in this case. So previous we are assigning this one to the null, current nothing but current to head, nothing but 1 in this case, next to 2 here. This is fine, easy to understand, right? Let's move on with the iteration part here. Different iterations, right? The first iterations here, as we are going with the iterative pointer reversal approach. So here in this case, reverse 1 to null here in this case. Reverse 1 to null. We will be moving the previous to 1, current to 2 here. We will be moving the previous, now previous is 1, current to 2, and next becomes 3 here in this case, right? So here in this case 1 to null. 1 will be null, means previous. This one will be null, sorry, reversing. So we will be moving previous to 1 and current to 2. Same goes with other iterations as well. Now what we will do, we will reverse 2 to 1. So 1 to null we reverse, right? So now we will reverse the 2 to 1. So 1 to null. Now 2 to 1. We will reverse 2 to 1, and previous becomes 1 and current becomes 2. Next step, previous becomes 1 now and current becomes 2, right? So accordingly with 1 2 3 4 5, previous becomes 1 and current becomes 2 now. So let's move on with the iteration 3 here. We will reverse 3 to 2. So we will reverse 3 to 2 now. So in this case, just give me a second here. Now next step is we are reversing 3 to 2 here. This is fine. So we will move the previous to 3. Now previous will be 3 and this one current will be 4. Right? The current will be 4. One step we are moving ahead. Right? So this is fine. Now we will reverse 4 to 3. The next one. Now we will reverse 4 to 3. This one. 4 to 3. Right? So now what happens here in this case? Previous becomes 4 and current becomes 5. This one I'm speaking of. Now previous was 3. Now previous becomes 4 and current becomes 5. We are moving step by step, right? Iterative approach. So the next step we will reverse 5 to 4, or the final step we will return 5 to 4 here in this case. So we will return 5 to 4 in this case. So now what we have here in this case, previous becomes 5 and current becomes null, because previous itself, previous was 4, current was null. So this is the last element that is found. This becomes previous and current moves to the next step. Current will be null in this case. We don't have any element. So current becomes null here in this case, right? So we will return previous, nothing but new head will be 5. So this one I'm speaking of. We will return previous. The finally here we will point previous to 5, right? The final one. Current becomes null in the final step. And we will return the previous, nothing but in this case it is 5, right? Previous will be 5. We will return in this case new head equals 5. So we have to reverse the list and return the new head, right? New head is nothing but in this case previous is 5. New head is nothing but 5 in this case. I hope this is clear, easy to understand, right? We saw all the iterations what happens. So now what we have here in this case, when we return previous, this will be 5. This one will be 5, right? This one will be 5. So this will be 5 4 3 2 1. Now 5 4 3 2 1. We have reversed this one. We have reversed this one successfully, right? This will be 5 4 3 2 1, right? These are the steps, right? So now we have 5 4 3 2 1. We have successfully reversed the linked list. Now we have 5 4 3 2 1 solution, which is equivalent to the output that they have given on the given for the example 1, right? So the approach works absolutely correct in this case, right? So now we are familiar with the approach. As we are familiar with the approach now, let's discuss the edge cases one by one. So the first edge case here is empty list, right? So the first edge case here is empty list. So here we don't have any nodes to reverse at all. So output will be empty array itself, right? In this case, output will be empty in this case. So let's move on with the second edge case here, single node. When I say single node, we have only one element here, 1, right? So here no change is needed as we have only one element, or as we have only one node here in this case. Output we will return the same here in this case, right? So let's move on with the third edge case here, 2 nodes. When we have 1 2, we have 1 2. So we will go with swapping the pointers. We'll just swap the pointer ones, right? So it will be 1 2 becomes 2 1. Just swap the pointers here in this case, or we'll just swap the pointers here in this case. The output will be when output is 1 2, it will be here 2 1 in this case, right? So this is fine. We are going with the 2 nodes. Let's go with the final edge case here, large list. Large list means when function should work efficiently within constraints. When I say function should work within this one, efficiently within constraints, they have clearly mentioned in the constraints that 5000 nodes. This has to be within 5000 nodes. We can consider 5000 nodes, right? It has to, function has to, whatever function that we write should work efficiently within the constraints that we need to keep in head. These are the edge cases that we need to consider here. The first one is for the empty list, the second one is for the single node, the third one is for the 2 nodes, and the final one or the fourth one is for the large list. This is fine, I think, right? I hope these edge cases are completely clear. Now we are completely this one. What do I say? Now we are completely familiar with the approach as well as the edge cases, right? As we are familiar with the approach and edge cases, it will be easier to write the code. Let's start writing the. So here the first step is we have to initialize the prev. We took three things, right? If you remember, previous to null, current to head, and next to the next element. So let's consider for the first step, let's initialize prev to the previous variable to null and current to head. So I'll just go with here. In this case, this is Java, right? So let's make use of the list node here. Just go with list node as we are going with the so this one copied entirely. So I'll just go with here list node. So it has to be capital here in this case. This is fine. So let me initialize previous to null as well as current to head. This is fine. The next step is we have to traverse the list until the current becomes null. We saw that final step, the current became null, right? When no element was present, then current became null and previous became 5. If you remember, the first example itself we considered in the approach, right? So that one we have to articulate that one in the form of code. I'll just make use of the while loop here, or while condition, this one here, while current not equal to null, then what we need to do here, we are traversing the list until current becomes null here, right? First thing here, we have to store the next node reference. We have to store the next node reference, means what is the next node referring to? That reference we have to store, right? We have to store the next node reference. So I'll just give here list node, this one next. I'll just assign this one to current dot next here. This is fine. I hope this is clear. So the next step here is we have to reverse the current node's pointer. We have to reverse the current node's pointer. Here in this case, this will be current dot next. This one will be equal to previous, right? So after reversing the current node's pointer, we have to move the previous to the current node. So step by step, we moved previous to the current node and current to the next node, right? So and current to the next node. These two steps we did every time, step by step. I showed this one in the by considering the first example, right? We saw this one. So that's what we need to articulate, or we are just articulating our thinking process or the approach in the form of code here, right? So I'll just give here previous equals current in this case. Nothing but we are moving the previous to current node. After that, we have to move the current to the next node. So we are moving previous to current node and current to the next node, right? So current here, this will be equal to next in this case. This is fine, easy to understand, right? The final step here is we have to return the new head. When I say we have to return the new head is nothing but the previous. We saw this one, right? So finally, in the final step, the current head, the new head was the last element, 5, if you remember, right? So that's what. So we have to return the new head, nothing but previous. In this case, return, we have considered the variable name prev, right? Pre for the previous. So this is it for the code. So let me format this one once and let me hit the run button. So here you can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So the code works absolutely correct in this case. So let's quickly discuss the complexities for the code that we have written. So the approach that we went with is, the first thing is, the approach that we went with here is iterative approach or iterative pointer reversal, right? So what would be the overall time complexity here then? So overall time complexity would be big O of n in this case. So overall time complexity would be big of n in this case. Why it is big of n here? We are traversing the each node once. We know that we are traversing each node once here. So overall time complexity will be big of n, right? So what will be the space complexity here? We are not making use of any extra space here apart from the pointers that we have made use of, right? Apart from the pointers that we made use of here, we are not making use of any extra space. So overall space space complexity would be quite obviously big of 1 in this case, right? So I hope this is clear. So the time complexity is big of n and the space complexity is big of 1 for the code that we have written. So I hope the complexity or complexities are clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.